Hello, and thank you for joining me. You're here with Data Science Teacher Brandyn, and we're going to go over smart watch prices using details about the smartphones. Okay, we're going to focus today mainly on gradient boosting, but really all of the ensemble methods to get a good sense of how they work differently and the different parameters that we can play around with each of them. Okay, so going to the first section, so we're going to do here, we're going to import some of our libraries. So from model selection, we're going to import train test split. And we're going to go from pre-processing, capital S, standard, capital S, scalar, standard scalar. And from the ensemble library, we're going to import, just make sure I'm connecting this as well while I'm writing these. So we're going to import random forest regressor, to import gradient boosting regressor, bagging regressor, and last one. Try voting regressor as well. This is not one that I've used a whole bunch, but it's a way to combine them. It's kind of more of a simple way to combine these models. There's more advanced ways that I would say are more commonly used. This is a very simple way to combine many models, or in this case, many ensemble models, into one final model that takes the predictions from each one of these and kind of aggregates them to give us our final prediction. So it can be a little bit more robust, but we'll try it out. I don't know if it'll work better today. Well, I guess I do because I finished the project, but we don't know at this point. We don't really know if it's going to work better. So we'll try it and really see. And that's the idea here is really in machine learning, we don't just try one model. We try many different models because there's so many interactions inside the data set that really our human brains just aren't smart enough to keep track of all of the things that happen, that could affect our predictions. So because of that, it's really good to try at least a few different models. I usually do like 4 or 5 different models. And then from there, figure out which ones are better and maybe try some subversions of the models to see if I can get it even better. But I start off with, the assumption that although I like random forest and gradient boosting, these are my 2 favorite models, I try other ones because they are not always the best. Even though they're my favorite, does not mean they're going to be the best. So I try to be unbiased and really let the data do the talking about finding out which models. Okay, so we see here we have lots of object type columns here, some kind of categories, a few numeric ones, and a few numeric ones that we'll have to clean up a little bit to be able to use properly, and a few, although they're not one hot encoded at this time, but one models that are like binary classifications, binary categories that we'll be able to convert into one hot encoded variables using yes and no. And then we have our price, which is going to be what we're trying to predict today. But we won't be able to predict it as it is. It would be a classification problem because they're going to be seen as objects. So we need to clean this up to be able to work with it before we can even do our predictions today as well. So looking at the dot info, as I said, we have lots of objects. Almost all of them, except for display inches, is seen as an object. So we know we have some problems in our numeric columns just getting started. So you can see it makes some notes of these. Just really keep creating a to-do list. And before we can even do our EDA, we got to clean these up so that the numbers and we can really inspect them in a full way. Because water resistance meters, it should be, when you look at the column right here, it looks like it should be a numeric one. So it's kind of weird that it's not. And it's good. I think when this happens, I like to use value underscore counts. Just get a sense of this. And usually there'll be a count of the thing that's causing the problems. And right here, it was someone wrote not specified. Instead of just leaving it blank, they left it not specified. That just makes it a little bit more complicated for us. And so here, now we know what we need to fix though. So now we know that we want to replace not specified with, what we'll do is we'll use the most occurring, the mode of the value. So here what we're going to do is we're going to replace not specified with of the value counts. It's going to get this one. It's going to get the value counts, then dot index is going to get just these index values here. And then 0 is going to get the first index position. So this is going to get 50 is going to replace not specified with 50, just a good kind of the most commonly occurring value, the highest frequency. Okay. Then in the next one, what we're going to do is we're going to fill the NA with the same thing as well, just to kind of clean this up right now, because this is an object column, so we can make sure everything's working properly. And now we have our 177. We have our values now, put 2 extra in this most occurring value, but now we have something that we can work with. Okay, so in our battery life here, what we're going to do is we see battery life in days. We do the value count on this again. And because this is an object column, we can see here we have unlimited and 48 hours. We have 2 different types of things that we want to do. Although they look very similar, what we want to do is we want to completely replace an unlimited one with this. We want to kind of change something to a string and put that string back there. We have to go, instead of just replace, we go str, so we get the string, and then we replace the values in the string, putting back the, well, whatever's left of that. So we're going to replace unlimited with 70. And we're going to place hours with just a blank string and get rid of the 48 hours and the spacing. Okay, and then what we're going to do is we're going to change this column into a numeric column. Now that we've cleaned it up, so we can just now convert it into a flow. So we'll be able to perform our mathematical operations in our machine learning section. Okay? So then looking at our price, we can see here we have to do the same thing as above. We're going to make changes to an existing string. So we're going to go string replace, because we want to put back that string. Okay, we're going to go string again, and then we're going to replace this. And so we're going to replace the $ and the column sign. You don't see it right here. Found this out after I experimented, is that there was some of these are over 1,000. So there's a comma in the 1,000 position to separate it. And so we're just going to replace that with 0, because it does not convert to a float if that is there. Okay, and then we're going to set this to as type float as we did before. Okay, so getting that one done, and now we have our numeric price column that we can now predict as a regression problem. You could have done this as a classification, but I highly doubt it would work very well, or it could be really highly overfitting and not give you good answers. Okay, because it would treat every single number. It's going to be very highly multi-class, probably a different number for almost every one of the rows value that you're trying to predict, and that's just going to be very confusing for you. Okay. So here, getting into, I just wanted to clear, so getting through this point, I don't know if you felt this way already. We didn't play around with the column titles, but as I was making this, I got kind of annoyed at the column titles having this white space. I should have done this at first. I didn't really inspect it quickly or well enough. But now that we're here, I just want to change and clean up the columns. I really want to get rid of this white space in this thing. So what I can do is click on one of these names and select the whole column title, and that will just save me a little bit of time as I'm working through my project. Okay, so here, what I'm going to do is I'm going to put the column names into a series so that I can call this replace object. So the string replace. We're going to make changes to an existing string. We're going to place some values in there. And what we're going to do is we're going to go for C in this list of values right here. Actually, what I wanted to show you first. So we're just doing a one-line if statement. So we're going to go if C equals to this. So do this. So do an empty. So do underscore if C is equal to space, else an empty string. So what this is going to do is when it's a space, it's going to replace this. And when it's one of these other 2 things, the parentheses, it's just going to get rid of those and put this. This is a one-line if statement. You don't always have a place to do this. And you can see here, if it's a space, what it's going to do is it's going to now output an underscore. Okay, so you don't have to do one-line statements. You can often just get by doing a normal kind of multi-line if statement. But where it really comes in handy is where we put them inside of a function. So this is, in this situation, it would almost be necessary to do this. And this gives a lot of flexibility. So what we're going to do is we're going to go if C is equal to a space. So if it's this last one, we're going to do is return underscore. However, else, if it's anything else but a space, what we're going to do is we're going to returning nothing, essentially, not an empty string, but just really nothing, no spaces. Okay, so that will clean this up a little bit and make us look quite a bit nicer. And we're going to assign those. We're going to do this all at once, and we're going to assign this pdf.columns back to df.columns. So we're going to be replacing over the column titles, and we can see now our column titles are cleaned up here and quite a bit better here. So we don't have any of the parentheses and then no more spaces. So now we can click on any one of these names and just get all of them. Super minor, but super handy and stuff as we get started. So, and doing the if. Okay, so another thing that we're going to need to do is we're going to need to clean up the resolution, because it has a x to simulate this multiplied by this, height by width. So what we're going to do, we're going to have to split that. And what that's going to do, it doesn't instantly fix our problem, but if we split on the x, what it's going to do is give us a string of every time it's out x, is split it in half by those, or split it into sections based on that. Okay. But what we're going to do, what we're going to need to do now is get that value, get each one of these values. So it's going to, there's going to be a height and a width. So height and then width. We'll be able to use those numeric values in our machine learning model. So we're going to create a little function. We're going to use it with a pandas function called .apply. So let's start by writing the function though. So we're going to go get dimension, so height or width, on the position 0, 1. So 0 would be this first position, 1 would be the second position. And we're going to go if x is equal to 0, then we're going to return 0. And this has to do with when there's a missing value. We fill it with just a 0. And then else, we're going to return the position, this value, but we're going to return it as a string, as an integer. So we're just going to pull this out and then return it as an integer. So that's just automatically, we don't have to worry about it again. And so we'll split this column. I just showed you the example here. I didn't save this, so we're going to actually save it, replace over top of the column right here. And then what we're going to do is we're going to fill an A with zeros. So if there are zeros, we're going to return a 0 as well. Okay. And then what we're going to do is we're going to go .apply and apply get dimension, and we're going to give it we're going to give .apply the arguments that it's going to pass to the getDim function. Okay? And then we'll apply this again. And so we create then the height and the width column, two different columns by selecting position 0 and position 1. And then if we want to create another column, what are the total dimensions of this? So we go total area is height multiplied by width. And we get 3 new columns now that we can actually use. And we got to spell them right though. 3 new columns that you can actually use in our machine learning model. And there we go. Okay. So we can see here, we have now lots of integers. We still have some objects, and we have but we have numeric columns that we can use in our, really just even in analyzing now. Okay. So let's start our EDA section now that we've done enough pre-processing to be able to understand what we want to understand about our data. Okay. So here what we're going to do is we're going to do a hist plot. We're going to be putting in, make sure there's no null features, but a hist plot and not in all capital. And we're going to do the feature. So we're going to go the feature for DF in columns. And then we're going to go, if it's not resolution, so that we can plot that one. And that's why we did the getDim function to make sure we get the actual value. So we don't want to look at this one again. So we're going to skip that. If not in that list of 1, what we're going to do is we're going to put the feature in from our data frame as long as it's not null. And then we're going to plot the same color values. And then we're going to do plt.title, plt.x takes, because there's quite a few values. Sometimes we wanted to be able to read that. And then we're going to make sure that we show this, print out the plot, so they don't just go on top of each other and make a nice plot, one for each one of them. Get a good sense of these. We have some outliers here. We have other ones that are a little bit exponential. And we have our target right here. So you can see that this is quite exponential. You could call these outliers. It's kind of like a semi-normal with outliers or an exponential distribution. So we'll try and put this to a log of the price. And what we'll actually try to do today is predict the log of the price, which is very easy to convert back to the price if we needed to. But it'll be much easier for our model to try and predict this distribution. We don't want to be truncating this too much because we really want to be able to predict these high values when they occur. We want to be able to predict this. And so if we treat them like outliers and leave it like this, it'll be harder for a model. So it makes sense to convert our price to a log of the price that we can easily convert back to the actual price if we need it. Okay. And so here's the notes on all the distributions that I wrote. I think good to review these. It's kind of like a to-do list. So it's kind of very helpful to have this. So this is the univariate analysis. Let's look at our bivariate analysis. Go choose diverging palette. Okay. Now this allows us to play around with the options and choose kind of a palette that when we use diverging palette, we know what these two numbers are. Okay, so you can do the high and low positions, play around with this, and the way it will print out kind of the different colors, maybe a little bit better, that's almost too much the same color. And you can go around and really just have fun with this, kind of what color would you want your two diverging, so one's going to be the high side and one's going to be the low side. What would you want it to be? Really kind of fun. You can have a lot of fun and play around with this for I'll get lost in it for a while here. I did not spend a lot of time watching me play around with colors. I'll let you play around with that. I chose some colors already that I think look quite nice. So 38 and 250. And we're going to put that in a seaborn heat map. Okay? So we're going to give it the data frame dot core, so correlation matrix. We want a note equals true. And for the CMap, we're going to put in our diverging palette, not the choose diverging palette, but just the diverging palette. And we're going to give it the numbers, whatever numbers you decided from up above. And we're going to say as CMap is true, and that gives us a nice one continuous palette. Okay. This there, we get a nice button. We can see we have some high correlations and some low correlations, but it always really, to me, makes sense to look at these correlations in terms of the target. We can get lost in this. We really be concerned with this price in USD right here, but let's look at it in terms of just focusing on that one column. What is the relationship with the target? Okay, so first what we're going to do is we're going to do a bar plot. Let's nest out bar plot, and we're giving it the values here. We're not looking at the highest correlation, core width, sort values, and then we're doing core width sort values, but here we're giving it the index. So it's going to be across the x value, and the y value is going to be the correlation with our target. Assigning that to x though, and we're going to ax, so an axis object, ax object. And if we're going to go ax dot patches, so for bar and ax dot patches, and this is going to iterate through, when you see this, it's going to iterate through each one of these. I'm going to go set line width and set underscore edge color. Okay, and so it's going to just make the edges a little bit, make them thicker and a little bit blacker, just add a little bit of extra texture to this plot. Okay, so we get a nice little correlation plot, and we can see here the battery life, very high correlation, well, the highest correlation, not very high, still very low, so it's at 0.14 maybe correlation, and then total area has the strongest negative correlation. You can see display size in inches really doesn't have a lot to do with the total correlation. It's very below a point, almost no correlation with the target price. Okay? And height and width tend to be more correlated, although negatively correlated. Okay. So here we're going to go processing 2. So we're going to do something. We're going to make sure that we fill all the null values now with the median price. So fill in the null values in a loop. And you can see here, we got all of the numeric features, all of the ones that were afloat. So we got rid of our, fixing our numeric features. We're going to make those work for us now. We're going to get his plot of connectivity. And what we're going to do is some of the dimensionality reduction. So I'm taking these values right here. I'm taking Bluetooth. I'm going to change it to Bluetooth Wi-Fi. I'm going to take Bluetooth Wi-Fi GPS, change it to Bluetooth Wi-Fi cellular, Bluetooth Wi-Fi and NFC, and change it to Bluetooth Wi-Fi cellular. Make this just reduce the number of different values I have so that I could use this in a machine learning model and I don't have so many features. Okay, so here we're going to do a his plot. And here what we're going to do is we're going to take we're going to truncate this. We only have one outlier hanging over here on the side, so we're going to truncate that, bring that in, and yes, the way we'll do is we'll do clip, and we're going to go upper equals 2. So we're going to bring these 2 in, just move that one a little bit to the left, to make this less pronounced and make it so that our model is not adapting too much to this outlier and really affect our overall predictions, at the sacrifice for predicting the outlier better, not predicting the rest of the data set very well. Okay? So you go through this, and the next one. Okay? So looking at the next section, we're going to look at doing the outliers for battery life as well. Here, so we're going to clip 30, bring those in as well. We saw those, and our clip. And I'm just notice that I'm assigning these to a new value, so I can choose that I want to use the clipped values and not the normal values here. I'm going to bring this into 30 right here and get rid of those outliers right here. Now doing a log transformation. So we're going to do a log transformation of battery life in days. So when we do that, here we're taking the battery life in days. It's not a perfect exponential distribution, but it is, if we add more data, it might follow exactly a normal distribution. We're going to do this to try and see if it works. And I left it so that you'll be able to experiment with this and we'll use one or the other in our predictions, but it will work. It will help in our predictions. And here, so we're going to do, this is an important one. Of our target, we're going to do log transformation as well. This is an exponential-like distribution. If we transform this into a log, you likely will be able to predict it well. I think significantly in this case, I tried it, but you will be able to test it later on, and that will be something. Don't listen to me. Don't listen to anybody. Experiment, right? So I said that it's going to work better. be skeptical, try out and see, what actually works better, because we don't know, right? It should work better, but this might be the interactions of this data set with these complex models. It might work better. It's not likely, but it is possible. So take the log and let's see, and we'll leave it open so that we can experiment and test both of these and really see which one works better. So this is the distribution after we take the log of the price. Okay, so the log price, it is a much better distribution. The average represents a good place in this. Likely we have a little bit of outliers, a little bit of tails, not outliers, but tails on either side, but those hopefully should balance each other out. So we're going to get pretty good predictions using the log versus the normal price. Okay. I'm going to do some one-hot encoding now of the GPS and the NFC columns. We're going to go pd.get_dummies info. So we're going to add some comments. So now we have quite a few more dummies right here. And now what we have is our remaining columns that we're going to put in here. And here we have the price. So we're going to assign a list of our features as we head into the modeling section, assign a list of our target, which is just 1 in this case. And we're going to then pull these out and put them into X and Y. So here you'll be able to change, if you change this to just the price USD, you'll be able to just instantly put this in. You can see here, we try the battery life clip instead of the battery life log and see which one really works better in this situation. Okay. So we're going to go and get into our train test, but so we make the list of each one of those to allow for experimentation and just checking here to make sure that there are no null values. And here what we're going to do is assign to X and Y the features in the target. Then we're going to go train underscore test underscore split, and we're going to give this our X and our Y that we just created, test size of 3 and random states. And so let's see our train right there. Okay. So here what we're going to do is standard scalar. We're going to go standard scalar is equal to std underscore scalar is equal to standard scalar, capital S scalar. Okay. And the reason that we're doing this afterwards is we're learning the mean and the standard deviation from only the train set to then convert the train and the test. We learned it from the test. We'll notice we'll probably get a little bit better score on average. It's called data leakage. We're not supposed to know anything about the test, so we can't use that to figure out things like the mean and the standard deviation to do our standardization. It doesn't seem like it would affect it a lot, but it is kind of cheating a little bit, so we want to be diligent about that to make sure that we don't, because you will notice you get slightly higher scores by doing that, and that is, again, we want to make it as hard as possible so that we're as confident as possible that our model will work in real life. We're going to then transform, so we're going to fit our train. We're then going to use the std scalar to then transform the train and transform the test from only what we've learned on the training days. Getting into our models of our modeling section. Okay. So here we're going to do gradient boosting regressor. We're going to fit that. So as we initialize it, we're fitting it with X train, Y train. We're then going to do score. After we send that to GB, we're going to get a score of X train and Y train. So our train score, and then we're going to get the score of our X and Y, our test set. Okay. The next one we're going to do, so we do that with gradient boosting. From that, as we go through into a random forest, let's do random forest regressor here. We're going to fit this just like we did above, and then we're going to score, and we're going to score this. So we get our train score and our test score. Okay, notice that I'm saving these. I'm not looking at them. You can look at them at this moment, but I'm saving these because I'm going to have a summary at the bottom where I put all of these into, and I can make the changes like experiment. I can maybe make a change here. I want to try the price USD versus the log, and then I'll just come back down to my summary and look at my final scores. So I'm not looking at the scores right now, but you absolutely can. There's no reason that you can't. Okay. Next, after we've done the random forest, let's do the bagging regressor. We're going to fit this, and then we're going to score the bag dot score again on the train and then the test set right here. So let's run this one. Make sure everything's working good. We're going to do the voting regressor. So this is an ensemble of ensembles. A little bit more complicated, but nothing really too bad. So here, just notice that I'm initializing 3 new models, and I'm doing this just for one little last thing so I could use the models in a prediction to look at the errors at the very end. So what I'm going to do here I'm initializing three separate models. I put the V for the voting because we're going to put this into the voting regressor. And what we're going to do, the way this works is you give it a string signifying the name of the model. So I'm just going to call it GB, and I'm going to give it GBV, this gradient boosting regressor. I'm going to fit this. Okay. So here you can see this now. So we're going to initialize this by giving it three models that have initialized with tuples in a list. So the name and then the model of each one of these, the name and the model, the name and the model. And I'm just going to fit this like a normal model, and I'm going to score it like I did in normal. So there's nothing super different in how you use it. I love it. sklearn is really truly quite easy to use. It is, I feel like it's like Excel. It's just so user friendly. It's just really easy to use. Yeah, so we've done that. I haven't looked at the scores yet. So let's see what we did. So I do a summary of a list of my train scores, a list of my test scores, the names of the models, and I'm going to put those into a dictionary. And then, as we've seen probably many times by now, if you've been following along with these projects, it fits very nicely into a data frame. So we're going to give the dictionary of our scores into a data frame. We're going to put the index as the models, and then we're going to go sort underscore values to put this as the test scores right here. We're going to sort by test scores, and we can see our gradient boosting got the best score today, 61%. So I spent a lot of time with this to try, because this is would be overfitting, right? So you would want to really try hard, and you can probably improve this a lot. What we want to do is try to decrease the train score and then bring the test score. Now that's the standard thinking. I actually like this. I think this is a good lesson, because ideally we want the train to be like, or the test score to be about 0.05, 0.02 less than the train score. And that we would say we have confidence then that it's not overfitting. It can happen though that we just do not have the data that we need. There's something missing, maybe like the manufacturer, maybe the location, a whole bunch of different things that could be a factor in that we're just missing the data. So our model, I tried, and maybe you'll be able to find a way to predict this, but I tried pretty hard on this, and this just happens sometimes. We're missing data at this point. We've done everything we can to try to fix this overfitting, and it's not working. So we know that we're probably missing something that our model really needs to predict well. Okay? But we're still getting good, and we can see that our gradient boosting does well. And I really like gradient boosting. It turns out to work really well. Random forest does as well. So these are two really good models. All of the ensemble methods, bagging works really well as well. And you can see what's interesting here is the voting gives us a good, although not an average, but it gives us a good, robust model over the gradient boosting by combining our three models into one. And you can play around with it. Lots of flexibility in how we play around. So it's good that we looked at these, but let's see kind of our scores so we can look at and really get a better understanding of what's doing well and what's not. So I like to use the Seaborn resid plot, and so we're going to do this 4 times so we can inspect each model. So resid plot, not resid plot right there. And then so we're giving it x as the train, our true values, and then we're going to predict on the, so these are our predictions right here. So our bag.predict, x train, rf.predict, predict. So then I'm giving them names in the label here. And the reason I'm going to put the label here is so that when I have the legend, it will know which one of each one. It will have the names that we can see here. So bagging, random forest, gradient boosting, and voting. And then the next line, I'm going to go plt.legend to get the plot to show, or the legend to show. And then I'm going to give it a title, and I'm going to do tight layout just to kind of, it really just kind of cleans it up and make sure everything's positioned well. If you start putting too many things in your plot, you can kind of mess things up. So I'd recommend that you try this without the log. It's a good experiment. There are definitely some ways to do some more pre-processing. I tried to keep this a little bit light as it's a level 3 project, but we can do a lot more pre-processing and see if there's a way to improve our score. Maybe in something that we could do, we could extract a manufacturer or the type of screen. Maybe those really do affect prices. They would need quite a bit of cleaning up, but it's entirely possible, and maybe for a more advanced project, we'll look at doing that. So thank you very much for joining me today, and I will see you next time.